See Lindelof videos? Geometry. Today we're going to be learning how to use parallel lines and transversals. This is going to be part 1 where I go over the postulates and theorems, and then part 2 is where I'll actually be finding measures of angles and doing problems. So, start off with, here are your two parallel lines. You know they're parallel to each other because they have this arrow here which indicates that they are parallel to each other. And then this here is your transversal, which could be a line, a ray, or a point that cuts the parallel lines. So the first postulate we're going to go over is the corresponding angles postulate. So it says here, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So we'll call this angle right here angle 2, and this angle here angle 4. They both lie on the same side of the transversal, on the right side, and they both lie on top of the parallel lines. Angle 2 is on top of this parallel line, and angle 4 is on top of this parallel line. So if we're following the corresponding angles postulate, we can say that angle 2 is congruent to angle 4. Okay. Now I'll move on to the next one, which is a theorem. It is the alternate interior angles theorem. So, let's use a different color. Okay, let's call this angle here angle 4, and this angle here angle 5. So, angle 4 lies on the right side of the transversal, and angle 5 lies on the left side of the transversal. However, they both lie in this space in between the two parallel lines. So because they lie in the interior of the parallel lines and on opposite sides, they are alternate interior angles. So if we follow the alternate interior angles theorem, which says that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So if we are following that theorem, we can say that angle 4 is congruent to angle 5. Okay. The next theorem is the alternate exterior angles theorem. So let's change colors again. It says here, if two parallel lines are cut by a transversal, which we have that there, then the pairs of alternate exterior angles are congruent. So let's call this angle 1, and we'll call this angle 8. I like the number 8. So they both lie on opposite sides of the transversal. However, they both lie in the exterior. They're not in between the two parallel lines, and they're also on opposite sides of the transversal. So if we're following the alternate exterior angles theorem, we can say that angle 1 is congruent to angle 8. Okay, last one is the consecutive interior angles theorem. So we'll erase that. Oh no, my little arrow went away. Fix that. And go to green. So it says for the consecutive interior angles theorem that if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So we'll call this angle 3, and we'll call that angle 5. So they both lie in the interior of the two parallel lines, and they lie on the same side. They lie, oh no, did I just erase another one? What? Why? Okay. No. Oh no! I just wanted to change the color. Sorry about that. So they both lie in the interior of the parallel lines, and they lie on the same side, which makes them consecutive interior angles. So if we're following the consecutive interior angles theorem, angle 3 and angle 5 are supplementary. Sorry if that's a little illegible. Okay, so that's it for this video. In part 2, I will be doing the problems and help find measures of the angles. Yeah, if you found this video helpful, please give it a thumbs up and subscribe, and I'll see you soon. Bye!